Alright, welcome. Now, 7.2 notes. Today, in the warm-up, the first few problems I'm going to do, we're going to see some numbers. Alright, but the main focus of today is variable bases. So, we'll get more into the numerical basis tomorrow, but it's a good place to start. So, 7.2 is split into 3 days, as you see on your assignment guide, so this is the first day. So let's say we said we had the cubed root of 27, and we did stuff like this yesterday. When we break it down, all right, we wanted to find groups of 3, right? Reason being, say we go 9 and 3, 3 and 3. We have 3 3s. So I can write this as 3 to the third power all to the cubed root. And that's why this equals 3, because in a sense, like, these 3's cancel out, right? If we had a square root, we would want it raised to the second power. All right, so let's say we have this cubed root of 16. Well, the cubed root of 16, we know 2 to the third is 8. All right, 2 to the third is 8 times 1 more 2. All right, so this 2 gets to come out, and this 2 stays in. Similar to if you were to break down 16, you would get, what do you want to start with? 8 and 2, which is 4 and 2, 2 and 2. So your 3 2's come out as 1, and whoever's left alone stays home. Just like square roots, but instead of pairs, we're looking for groups of 3. All right, so now let's talk about variables. So if I have the square root of x to the 4th, all right, well, think about it. I would have x squared, x, x, x. All right, another way to think about this is, since it's a square root, and this is how I like to think about it, what to the second power is 4? Well, x squared squared. There's a 2 out here, so these are your matching pieces, and the x squared comes out. So if we had the cubed root of x to the third, how would I write x to the third power? Well, it already is, so x comes out. All right, so that's kind of the groundwork, the basis for our thinking. So let's get into it. Now, today I'm bringing the real deal Holyfield. All right, we start breaking things down, and we're getting into some real algebra skills. All right, so let's do this. Now, we're going to start with simplifying. All right, we got 4 aspects to today's lesson. All right, and simplifying is the first one. So, the cubed root of x to the 4th, the 4th root of x to the 10th, and the cubed root of 8x to the 3rd, y to the 6th. Let's start with those 3. All right, now here we have the cubed root. So how many x to the 3rds are in here? Well, I would have x to the 3rd power would take care of 3 of these, and I have 1 left over. So this one has the magic key to come out. This guy's stuck in to the cubed root. All right, so we got to find, with this number out here, it tells me what to this power, how many of those do I have here, and then what's left over. So now this one gets a little trickier. Okay, x to the 10th. Well, how do I write x to the 10th to the 4th power with the least amount of remaining x's? All right, well, so I can make 8, right? 8's probably the closest number divisible by 4. So I can go x squared to the 4th. And how many x's are left over? Because that covers 8, so that means there's 2 left over. So x squared gets to come out, because again, these 4's match, and x squared is left inside. All right, so you see how that works? All right, over here now, can we write 8 to the 3rd power? Yeah, 2 to the 3rd. X is already written to the 3rd power, so that's nice. y to the 6, how do I write y to the 6 to the third power? Well, y squared raised to the third. That gives me 6y, sorry. So this is all still to the cubed root. So 2 has a key to come out, x has a key to come out, and y squared has a key to come out. Nothing's left inside. All right, not so bad. Let's try 3 more. All right, let's go. The cubed root of 24, x to the third, y to the fifth. The cubed root of 2x squared times the cubed root of 4x to the 7th. And then x to the 1/4 times x to the 5/3. Okay, again, how do I write 24 to the third power? Well, I don't really know. This is a tough one. So I'm going to go breaking it down. So we have 6 and 4, 3 and 2, 2 and 2. All right, I have 3 2's, so that gets to come out, and 1 3 is left in. Okay, similar to breaking down square roots, again, we're looking for 3's. X to the third, well, that one's easy. Now, y to the fifth, well, I can go y to the third, and I have 2 left over. So this y gets to come out, and this 2 is stuck in. All right, so that's my answer right there. And this is a cubed root. That stays the same. Over here, now, when these guys match and they're being multiplied, it's really just like combining like terms, because I could raise it all to the 1/3 power, and they would have the same power. So it's the cubed root. Now, again, they're the same. So 2 and 4 give me 8. X squared and x to the 7th gives me x to the 9th. Well, 8 is the same as 2 to the third. X to the 9th is x cubed to the third power. So 2 gets to come out, and x to the third gets to come out. Then over here, we have x to the 4th times x to the 5/3. We add our exponents to get x to the 23rd over 12, 23 over 12. Put in your calculator. 1/4 plus 5/3, math frac. Now I can rewrite this, remember from yesterday's lesson, as x to the m to the nth root. Excuse me. So with that, how do I write this to the 12th power? Well, I have x to the 12th, and there's 11 x's left over. So who has a key to come out? Well, x does, because the 12s match. And then x to the 11th left to the inside. All right, so simplifying, that's the beef of the lesson. All right, now for the next phase. This is rationalizing the denominator. Now, as you remember, you are not allowed to have a square root in the basement. Same rule applies, just we're not allowed to have cubed roots in the basement or 4th roots. So it gets a little trickier. So let's start with this one. 5 over the cubed root of x. Now, in order to get rid of this, you have to multiply by a perfect cubed root. All right, remember when we used to do like this one? Okay, the square root of 2. Well, we would multiply by the same root 2, because by multiplying by a perfect square, root 4, I'd be left with a number on bottom. All right, we need to accomplish that same thing, but it's a little different here. Now, to have a perfect cubed root, I need 3 x's. I have 1 already. So how many am I missing? I'm missing 2. Okay, again, I'm going to say that. I need a perfect cubed root. Here, I needed a perfect square root, so I added another 2. Here, I need a perfect cubed root, and I have 1x, so I have to add 2 more, because that'll give me 3 total x's, which will, in result, get rid of my square root in the denominator. So I need to multiply by the cubed root of x squared up here. All right, so my result is I multiply straight across 5 times the cubed root of x squared all over. Now here, when I multiply these two together, my result is the cubed root of x to the third, because x times x squared is x to the third, and I'm just left with x. Alright, so the goal is you need to make a perfect square at the bottom, in this case a perfect cubed root, to make it happen. Alright, I know this is a new concept, but let's try another one. X to the sixth over y squared, all to the cubed root. Alright, the first thing I like to do is split it up. Alright, so we're dealing with the cubed root of x to the sixth and the cubed root of y squared. Alright, well, the cubed root of x to the sixth we know is x squared. So let's simplify that before we start messing with everything else. Now, I have two y's. How many do I need? I need 3. So I'm missing the cubed root of just one of them. And you got to be consistent on top and bottom. So on top now I have x squared times the cubed root of y all over. Now I have 3 y's on the bottom, so it just spits out a y. Alright, so that's rationalizing the denominator. Alright, now adding and subtracting square roots, cubed roots, fourth roots. Alright, so now we're adding and subtracting. So let's say we have 2 times the fifth root of y plus 7 times the fifth root of y. Now, just like before, it's important that the square roots, your roots match. So here our fifth roots match. So because they match, we can add the coefficients in front. It's just like adding 2x plus 7x. They both have x's. These both have y to the fifth root. So we can add 2 and 7 to get 9 times y to the fifth root. That's it, just like combining like terms. So what if I gave you the square root of 4x to the fifth minus x times the square root of x to the third? So sometimes they need to be simplified first. Well, the square root of 4 is 2, okay? So now we're talking about pairs because it's a square root. So a 2 comes out. Now x to the fifth can be written as x squared squared is 4 of them, and I have my fifth one left. Alright, so x squared comes out, x is left in. Over here again we have a square root. So this can be broken down into x squared times x. We already have an x squared, 1x out here. Alright. Again, this 2 is with the square root. So 1x out here, I'm taking another x out. So that gives me x squared, and I have 1x left in. Now, my roots match. I have square root of x, square root of x. So 2x squared minus 1x squared is just 1x squared. And the like term stays the same. Just like up here, 2 and 7, 9, your x stays the same. You don't mess with those at all. Alright, so adding and subtracting, sometimes you need to simplify first. Alright, now let's talk about irrational exponents. Irrational exponents. Alright, so let's say I have x squared times x to the square root of 3. Now we know when we have the same base, we add the exponents. So x squared plus root 3. That's it. Alright, let's try one more. X times y all raised to the pi. Well, same laws apply. Take the pi to both. X to the pi, y to the pi. What about x raised to the 4 root 2 over x to the root 2? Well, again, it's who wins, or we're subtracting, right? So x 4 root 2 minus root 2, they have the same square root, so the top, it's going to stay on top. 4 root 2 minus 1 root 2 is 3 root 2. Alright, so let's deal with the irrational exponents. Whew! I know I threw a lot at you, and I know it's new. Tomorrow in class, I'll have a handout for you. We'll walk through each of these again in your groups and then go over the answers. See you tomorrow.